Can everyone hear me? All right. Hello, my name is Zachary Weinberg, and I'm presenting my paper, Topics of Controversy, an Empirical Analysis of Web Censorship Lists. This is joint work with my co-authors Mahmoud Sharif, Janos Shurdy, and Nicholas Christen. We're all at Carnegie Mellon. So to begin with, I want to summarize how everyone measures web censorship right now. You make a big list of web pages that might be censored. You somehow get access to a vantage point computer in the country of interest. You try to access all those web pages. Maybe you just make a TCP connection. Maybe you download the whole thing. Details vary. And you look for suspicious errors or overt block screens or whatever. And you can, and people have written in entire papers about all four of these steps. This is a paper about step one. How do you make a good list? So let's talk about some criteria for probe lists. I'm proposing that a good probe list has many different kinds of censored material on it so that you fully explore the space of things the censor might care about. You also want many sites for each type of material so that you know to what extent the censor cares about a particular thing. You want active sites, not abandoned ones, not ones that have gone offline or been taken over by spammers. And in tension with these criteria, you also want an efficient list that can be probed quickly with a slow network, because often these are very slow networks, and you want little manual work to keep it up to date. And again, I could write a whole paper about each one of these things. Today I'm only going to be talking about breadth and, to a lesser extent, freshness. So to explore how well people are doing right now on breadth, I got some existing lists. There are 22 lists here, total of 760,000 unique URLs, and they fall into three broad categories. The top 15 on this slide are alleged actual blacklists. Somebody leaked information that says, I claim that this is the list of things that get censored in this country at this time. They're one-time snapshots, they're really easy to overinterpret, and they are often from very low credibility sources, but we hope we can still learn something. I've split them into the lists that are overwhelmingly porn and the lists that are not overwhelmingly porn. And the bottom third is comparison lists selected 7 different ways. 3 of them should have more correlation with censorship than average, and one of them in particular is the OpenNet Initiative's probe list. So they have manually curated a list of things that they think are relevant for censorship monitoring. One of them is a negative control. It should have fewer censored pages than average. And the final 3 are supposed to be samples of the more popular parts of the web, and in particular, Common Crawl, which is an outfit that tries to do sort of an open source web sample of the entire web. We use that as a uniform baseline in some analyses. So the first thing you might think to do when you get one of these is just do Jacquard similarity. What proportion of the lists of the URLs in list 1 also appear in list 2 and vice versa? And what pops out here is that the pink lists have a lot in common with each other. That's the overwhelmingly porn blacklist. The comparison lists also have a lot in common with each other, and most of the non-porn blacklists don't have a lot in common with either other group or with each other. And okay, that doesn't really help. So the research question that I'm going to concentrate on in this talk is, how can we make a more meaningful comparison? And our key hypothesis is that the reason a page gets censored will have something to do with its topic. So we could do some natural language processing and compare the topic distributions of each list, and that should tell us something interesting. Now, to determine the topics of web pages, first you have to get uncensored copies of each one. So I'm assuming that my data center in New Jersey is seeing a completely uncensored web, at least right now, and I download copies of all 760,000 pages, at least all the ones that still exist. Roughly 40% of them don't still exist. And I did some natural language processing to identify their topics. It's obviously, each step of this is non-trivial. We have to run JavaScript. We have to detect all the pages that have been taken down, try to backfill from the Internet Archive. And then once you have them, trying to program a computer to understand what they are about is sort of the canonical AI hard problem. If you could do this, you would have built a human equivalent artificial intelligence. And that artificial intelligence would then refuse to do this job. For the same reason I don't want to do it by hand. But the great thing about AI hard problems is you can get really far with a crude approximation. So this is our process for one web page. So imagine that this is a web page as downloaded. It's got this fancy banner and some pictures and navigation links and maybe an ad off at one side. We don't want any of that. We only want the text. We don't even download the images. We use some heuristics to strip out the main text based on the principle that more heavily marked up text is likely to be boilerplate. If you have a better idea for how to do this step, by the way, come talk to me. It doesn't work perfectly. And once we have the text, we then identify the languages. And I should say that 40% of our documents are in more than one language. So we need to be able to identify runs. This is, for instance, here, this top bit is Latin and the bottom bit is Greek. There are off-the-shelf things that do that. Next step, we translate it word by word into English. This is mostly for budget reasons. We can't afford to pay Google to do the entire documents, but we can afford to use it as a dictionary. The reason we do this is that we have to have everything in the same language for the next step, which is called latent Dirichlet analysis clustering. And this is a standard NLP technique, and you take a bunch of documents, reduce them to word vectors, and then it gives you clusters of documents that have more in common with each other than with anything else, and it gives you a list of characteristic words for each cluster. And this is great because the characteristic words usually make sense to a human, and we can have someone just look at the characteristic word lists and stick labels on them. So for instance, in this case, Stoic philosophy. So on the actual data set, instead of the example, here's the 64 labels for all the pages we downloaded. And then I classified the topics into categories. So we've got a whole bunch of news and some commerce and some entertainment and some religion and what I call scholarship. There's porn, there's software, there's a bunch of junk. We are not as good as I would like at stripping out all the dead pages. Some major famous websites generate error messages with HTTP status code 200. Don't do that. Please don't do that. And I think probably the biggest problem we have is that we cannot translate everything. There's only so many languages for which you can get either an identification or a translation. But if you look at this list, it generally makes sense. It's what you would kind of expect a very high-level sample of the internet to cover. There are no obvious gaps. So now we've got this, let's take a look at which lists are concentrated on which topics. So very briefly, and I don't expect you to be able to read this, it's huge. This is a correlation matrix between the source lists and the topics. Wherever you see red, that means some list has more of some topic than average, and blue means less. Average is defined by common crawl at the bottom, which is why it's all white. And the thing you should be looking for is the vertical red stripes, because that means that some group of lists share a bias toward a particular topic. And I'm going to zoom in on a couple of interesting cases. So first, I'm going to compare the blacklists. So these are the allegedly, this is actually censored in some country that's not all porn. And I'm going to compare that with the OpenNet Initiative's probe list, which is primarily concerned with political censorship. And so, of course, they concentrate on these news and politics topics. And the blacklists also do that, but they tend to be concentrated on specific news topics. So we've got here India, Russia, Syria, and Thailand censoring news related to themselves and their immediate neighbors, and not so much other countries. That's not really surprising, but it's nice to see that we can pick it out. And on the far right, we can also see that ONI may be underestimating the amount of censorship related to social media. There's lots of evidence that authoritarian governments treat social media as a primary threat, so that's maybe a mistake. And we also see more entertainment topics like music and video and TV in the blacklists than ONI anticipates. And so I'm speculating there that that's about copyright infringement, that this infrastructure that's either was built to enforce copyright laws and is being repurposed for political censorship or vice versa. The other interesting thing we can find is that the pink lists aren't all porn. The classifier finds a bunch of sites in the German list that are related to German and extremist politics. I spot-checked a few of those, and yep, neo-Nazism. Similarly, the classifier finds Thai and Chinese political sites and social media in the 2007 Thai pink list, and those are consistently critical of the Thai royal family. And in both cases, this is not news, but the great thing is I didn't have to wade through all the porn to find it. On the other hand, this also shows a misclassification. There's a bunch of sites labeled as Russia on these lists, and I spot-checked as many of them as I could stomach, and they're mostly sketchy dating websites. So that maybe should have not been treated as Russian news. Can't be perfect. In the time I have left, I'm going to switch gears a little and talk about the freshness of these lists. Many of my source lists are 5 to 10 years old, and half the pages are gone already. So I used the Internet Archive to try to find out how long ago each page got taken down and how long it lasted. And then I did a survival analysis that will tell me roughly how long the typical page in each category tends to exist. So this graph is what's called a Kaplan-Meier survival estimate for each category of topics. So at the start, all the pages exist, and then as you go along, it shows you the fraction of pages that still exist. So notionally, they all came into existence at the same time, and then some of them drop off as you go ahead in time. So regardless of the topic, roughly a quarter of the pages are gone after 4 years, is the sort of high-level conclusion here. And then there's a bit of a knee. And another interesting thing is that pages classified as religion, commerce, and scholarship tend to be longer-lived than pages that are news or entertainment or porn. But that's maybe not the... Another thing we could try to look for is, here we are, we're researching censorship. Do we need to worry more or less than average about our pages going away? And so again, from survival analysis, this is what's called a Cox proportional hazards model that predicts the odds of a page being taken down with the independent variables of the topic category and the list category. So I can say from this, well, is the stuff on any given list, regardless of its topic, more likely to go away, or vice versa, or is there an interaction? And what this says is, yes, we do need to worry more. There's this big obvious outlier where non-pornographic video lasts a long time. This is mostly because YouTube has been around a long time and isn't going anywhere. But what is really important is that each letter, which is a topic category, in the right-hand 3 panels, which is the 3 classes that are thought to have more censorship on them, is higher up the chart than the same letters in the left 2 panels. And the vertical axis is logarithmic, so we get 5 to 10 more times more likely to go away, regardless of topic, if you are on one of these more likely to be censored lists. And especially, the non-pornographic stuff hiding in the pink lists is more likely to go away than anything else. I don't have any idea why this is, but what it says is that if you're developing one of these lists, like the ONI's probe list, you need to stay on top of the pages going away. So, in conclusion, we learned that censored topics are highly country-specific. Censored sites are more likely to go away than average, and this topic clustering can pick out interesting details of these leaked censorship lists. And so going forward, I'm hoping to turn this into a system for maintaining the probe lists in a more automated fashion than we can do. That's all. I'll take questions now.
Okay, let's thank our speaker.